advantage of you can also go back and see the recording if you want to. Now, last time we were discussing how charged particle behaves in a magnetic field, and now we are making a good use of that. One thing that we can make with this kind of arrangement is a speed selector. Now, for example, if we have a region where we have a uniform magnetic field, and we can produce this magnetic field by keeping two magnetic poles, opposite magnetic poles, very close to one another. So this is a beam of charged particles with assorted speeds. So what will happen is charged particles will come in because they're not having the same speed. So what will happen is some of them will bend in a circular way like this, and when they go out of the magnetic field, they again continue on a straight line. Some go like this. This is also a circular path. Some go like this, and some like this. So whenever they come out, they come out in a straight line. So now, and the particles are coming out from every point. Yeah. Okay. Now, if this is X side and this is Y side, which particle you can guess is the fastest? If you go back and recall the previous lesson, you will understand the speed and radius are directly proportional to one another. That means Y, because it is moving in a bigger arc. This arc is a part of a circle with larger radius. That means Y particle is the fastest and X particle is slowest. If we know the strength of the magnetic field and charge on each particle, we can actually calculate speed of any particular particle, okay, based on its position where it comes out of the magnetic field. And how can we put this into a good use? See, we can prepare two gates or two barriers actually. And we can place them like this. Just one second. Okay, now we can put the barriers here. They, for example, are made of lead, so they absorb all the particles, and they only let the particle go through the small hole. So all these particles, they are stopped. So no particle is coming out. All these particles are stopped. They are stopped here. Only these particles can come out. So we can select particles with any speed. For example, we are doing an experiment, and in that experiment, we need alpha particles or protons or electrons with a certain speed. What we can do is we can make them pass through a magnetic field, and with using these kind of gates, we can only let particles with particular radius come out. With that particular radius, they come out with particular speed as well. One thing that you have to understand over here is, note, magnetic field only changes direction of motion of charged particle. No change in speed. And why is that? Why there is no change in speed? Because if you remember that the force that was acting because of the magnetic field excuse me, the force that was acting because of the magnetic field was always perpendicular to the speed. If force is perpendicular to the speed, it means it is neither acting forward nor acting backward. So it will not accelerate or decelerate the particle. So speed of the particle will not change, only the direction will change. No work is done along or opposite to the direction of motion of particle by magnetic field. Magnetic field is not exerting any force along or opposite to the direction of motion. That's why speed is not supposed to increase or decrease. And only a particular speed can come out. Okay, if this is interesting, let's make things more interesting. I have to make a diagram. Stay with me on this one. I will try to be as quick as possible. Okay. What I'm trying to show here is that there are let me first make just two magnets. Okay, this diagram is trying to show that there are two magnets on the top of one another. This is north pole of one magnet and this is south pole of the other magnet. Okay, so they will be producing a uniform magnetic field in between the poles, north to south. Okay, and a charged particle which goes in experiences a force, and if it is a positive charge particle going into the magnetic field which is north to south, so if your fingers are pointing towards south like downward and your palm is pointing towards right, you will see your left hand thumb is pointing something like this. So the particle should bend like this and then pass through like this in the magnetic field. But we don't like stop here. We make another change. I hope you can see that north and south pole of two magnets are right in front of one another, like this over here. So what we do is, let me make some changes here. I'm bringing two more plates here. This is one plate. This is another plate. Okay. And these plates have a different kind of field now. This plate is positively charged, and this plate is negatively charged. And they are connected to a battery where we can change the power of the voltage or the potential difference between the plates. So what we have here is, this concept is called cross fields. We call it cross fields. Now we have two kinds of fields. One is the magnetic field and the other is electric field. Now a charged particle is coming in like this. It is the same positive charge particle. Because of the magnetic field, it should experience force this way. But because of the electric field, it should experience force this way. Now, if electric force is more than magnetic force, particle will go this way. If magnetic force is more than electric force, particle will go this way. And if both forces are equal, then particle is supposed to go straight. This is magnetic force. This is electric force. Now, let me make another two-dimensional diagram because they are easier to understand. They are easier to understand once you see the 3D structure of things. So the blue region is showing a uniform magnetic field. So the magnetic field is from this point of view into the plane of the screen. Upper plate is positive. And the lower plate is negative. One second. Okay. Now, beam of positively charged particle with assorted speeds and charges. They're all positive, but they have different amount of charge. Now, some of the particles end up at position X. Some of the particles, they end up at position Y. And some particles, they end up at position Z. Okay. Now, when we talk about the electric field, it is force divided by charge, or electric field is also potential difference between the plates divided by distance between the plates. So electric field has two formulas, and force equals to electric field strength into charge. This is electric force. What is magnetic force? B Q V. Now, look, which particles will end up at X, Y, and Z? Before that, let's see, because they are positively charged particles, electric force will exert a force in the downward direction because electric field is downward. So this is electric force. This will be
magnetic force.
magnetic force. Now, for X particles that end at X equals to, okay, it should be like 4 particles that end up at X. Magnetic force is more than electric force. BQV is more than EQ. Now, for particles that end at Z, force due to magnet is less than force due to electric field. The force of electric field is stronger than the force of magnetic field. So BQV is less than
EQ.
EQ. And that will make another inequality. But those particles that are ending at Y, for particles that end at Y, magnetic force is equal to electric force. BQV equals to EQ. Q and Q can get cancelled. Electric field divided by magnetic field. So this is a very important setup that can be used to find speed of the charged particle. I hope you, when you see that some information are given given for the speed of electrons and speed of protons, I hope you understand that those speeds are not measured by making a charged particle move at certain distance and measure its time, because an electron can move around Earth in less than a second. It can go around the whole Earth in less than a second. So how would we measure the time which is that small, and how will we detect the presence of electron at one point and then another point and make sure that it's the same electron? So how do you think we know the speed of such fast particles? Not by measuring distance and time. This is a very easy technique, because we can measure the strength of the magnetic field density. That is easy. We can control the strength of the electric field. And once we control these two things, which are very easy to control by, listen, how can we find electric field? It is potential difference divided by distance. So we need a voltmeter and a ruler for that. Everything is very easy to measure. And we can do some calculation and find out the speed of the charged particle. So this is a setup, cross field setup, that can be used to find the speed of the charged particles. Actually, I'm not feeling very great today. Can we make the class short for today as well? Thank you very much.
Sure, sir.
Thank you.
You're welcome.
Okay, sir.
Sorry?
Get well soon, sir. Get well soon.
Thank you. Thank you. Thank you very much. Thank you very much.
Okay, sir. Assalamu alaikum. Have a nice day.
Wa alaikum salam.